Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Azwa Syahda binti Samsudin, student supervised by Associated Professor Dr. Aspadillah Alias. So I am going to present about my study entitled Geometric Morphometric Analysis for Age Prediction, Thoracic Vertebral Study. So these are the co-author of my study. So as you can see, this is the picture of the 12 thoracic vertebra, or we can call it as T12. And these are the content of my presentation. First of all, we will start with introduction, and next, objective, methodology, results and discussion, conclusion, and also some reference. So, first of all, forensic anthropology is a field that involves the analysis of human skeletal remains to determine the identity of the individual, including their age. Geometric morphometric is the statistical analysis of form based on Cartesian landmark coordinates and capable of capturing morphologically distinct shape variable. 3D geometric morphometrics is used to study the shape and size of objects in 3 dimensions. In this case, it is used to study the thoracic vertebra for age estimation. So for the objective of this study, it is to improve forensic age estimation techniques, which can aid in identifying individuals for legal or investigative purpose. As for the specific objective, it is to determine whether there are any differences in thoracic size and shape variation between different age groups in Malaysians. So, the first step of the methodology is we need to put 50 landmarks on the CT scan of the T12, and as you can see in this video, it shows how we put the landmark on each part of the T12 vertebra. Landmarks on the T12 in geometric morphometric analysis are likely used to capture and quantify shape variations in this specific skeletal element. These landmarks serve as reference points on the vertebra. The next step is we need to run the analysis for the data that we got using Morpho-J. From the analysis, we will get the generalized procluster analysis, principal component analysis, canonical vary analysis, discriminant function analysis, and then we will identify the group for the age that we have. We divided the age to 3 specific groups, which group 1 that consists of young adult age group, uh, 18 to 30 years old people. For group 2, middle-aged adult group that consists of 31 to 50 years old, and group 3, old age adult group, which consists of 51 to 70 years old people. This figure shows generalized procluster analysis (GPA) that consists of a scatter plot of the superimposed landmark configuration, which overall are 50 landmarks. Here we can see the blue dots, which represents the mean landmark position, and the black dots, which represent the landmark positions for individual configurations in the sample. From principal component analysis, which is PCA, we can see that the first 10 principal components exhibit 54% variation in thoracic shapes, with the highest is from PC1, which is 11%, and the lowest is from PC10, which is 2%. Uh, Move to procluster ANOVA. So table 1 shows the sum of square, mean square, degree of freedom, statistics, and also the significance level, which is p-value of the centroid size and shape. Here we can see that there are no significant difference in centroid size, but there is significant difference in shape, which we can see the p-value is smaller than 0.001 between each age group. In canonical vary analysis (CVA), We found that there is a significant difference between the three groups. But first, we can see that the red one is for age group 1, which is young adult age. The green one is for age group 2, which is middle age adult group. And the blue one is for age group 3, which is old age adult group. So, after analyzing it, we can see that age group 2 is located between age group 1 and age group 3. However, the highest difference that can be seen is between age group 1 and age group 3. Next, we will take a look at discriminant function analysis, which is DFA. For your information, DFA is a statistical technique used for classifying a set of observations into predefined classes. This technique identifies the linear combination of variables that maximize the difference between groups while minimizing the variation within groups. So we can see that the classification rate from cross-validation analysis show that thoracic vertebra T12 were accurately classified in more than 50% in each comparison. And as we can see here, for group 1 versus group 2, after cross-validate it, we get 59% results. And as for group 1 versus group 3, we get 71%. And for group 2 versus group 3, we got 53.5%. So from the study, we know that geometric morphometric analysis in thoracic vertebral studies for age prediction involves the quantitative assessment of shape and size variations. By examining the morphological changes in vertebra, researchers can potentially identify patterns associated with aging. It can also contribute valuable insights into age-related changes in vertebral morphology, aiding forensics and anthropological investigations. Potential variations in population-specific patterns and the need for large and diverse datasets for robust predictions is the challenge for this method. So the integration of geometric morphometrics with other age estimation techniques can enhance overall reliability and applicable in forensic contexts. In conclusion, this study highlights the utility of 3D geometrics as an effective method for analyzing the shape and size of thoracic vertebra, specifically in the context of age estimation. On the other hand, the study revealed significant age-related variations in thoracic vertebra shape in Malaysians, highlighting the potential of geometric morphometrics to provide valuable insights into skeletal variations. So here are some references that are related to this study. That's all for my presentation. Thanks for watching.